Hello, everybody. Welcome back to another episode of Ruby for All. Julie, what's up?
I feel like I'm on a cruise ship because I was on a cruise ship over the weekend and I still feel the rocking. So
Did you
there's
get
that.
Seasick?
I do. I had to take a seasickness pill the first evening that I was on the ship.
I have never been on a cruise ship. They look fun, I guess. Smaller vehicles I find more enjoyable just because I'm like, okay, I can see everything happening around me and it's not going to take me 30 minutes to turn like 3 degrees, but they look like fun. Did you have fun?
Yeah. So this one actually had cool things on it. There were 2 legit water slides. You had to be of a certain height in order to go down the water slide. And they had a rock wall. They had a bunch of activities. We did stop at one stop somewhere in Mexico, but I didn't get off the boat because there was just so many activities to do. And I do enjoy cruises. So this was probably like my somewhere between 5th and 10th.
Oh, wow. Well,
Yeah.
Next solo episode, we'll have to talk about that more. I'm very interested, but today we are focused because we have Andy Atkinson. Andy and I have met at conferences. I think he's met Julie at conferences. Find him all over the web. And we are going to talk about some really cool stuff today. So Andy, welcome to the show. You want to give a little introduction?
Thank you. Yeah. Happy to be here. Really excited for the podcast and have been a listener. So excited to be a guest. I work for a startup and I mostly do Ruby on Rails web development, but increasingly the last couple of years I've been working with Postgres, and I've used Postgres with web applications for probably a decade, but I've been more interested in kind of the administration side and the operator side and just being more of a specialist with the capabilities that it has. And then also kind of the educational piece for other developers. Like, hey, did you know Postgres can do that thing? That kind of fires me up.
You're the database wizard that us web app developers look at longingly and like, how do they do that? And like, it would be really cool to do that. And then you start doing it and you're like, maybe I'll let that guy do it.
I feel the same way about folks that have deep internals knowledge or deep administration experience. I'm interested and motivated to learn in a similar way, maybe not so much coding or development, but like, how do you operate the database in a really secure, really reliable fashion and that sort of thing. And then internally, like all of the computer science that's baked into the data structures that are part of the database that help us with, fast retrieval and fast writes and scalability and those kinds of things. So yeah, there's so many layers of abstraction that are interesting, and it's a really deep and broad technology.
Yeah. I remember I was in a SQL class. I was supposed to be learning SQL at the time, but at the same time, I was interning at a company who had just handed me Ruby on Rails for the first time. And I was like, wait, why do I have to write SQL? Because I can see all the SQL in these logs and like, I didn't have to write any SQL. So I took it to my teacher for my final project. I'm like, here's all the SQL calls. And she's like, well, I guess you got an A, but I'm watching you. But Julie has a lot of really great questions that she sent to you, and I'm going to let her get right on into them because we got a lot to talk about.
Yeah, I'm really excited to have you on the show today. I started looking into more database things last month, and I found out that there were quite a few questions that I had that I was curious about as I was looking into. But maybe, I don't know if it should be called SQL or SQL, because I hear different things and I see that all over the place where I think there's supposed to be a standard. I don't know what it is.
Yeah, there's a lot of things in databases that have, it's interesting too, like even names between different database engines like MySQL and Postgres. They'll have the same concept, but will have different names. And it can get in the way of learning the technology where, especially if you're going from one to the other. As far as SQL or SQL, even in the name Postgres, this is debated where usually when it's written out, the formal name is Postgres, and then, but like the S on the end is the start of SQL. But usually when people speak it, they just say Postgres. But I know formally, if you write it, it's written with the capitalized SQL on the end. As far as like speaking, talking about, I think in my experience, SQL is most used as opposed to when you're talking, spelling out the letters. But of course, like if you're writing, you would write the acronym structured query language. You'd write out the letters capitalized. So I guess that's my thoughts on that. I would typically say SQL.
I will also say SQL as we continue on to the rest of the podcast. So one of my questions was, is there a difference in speed as far as using MySQL and PostgreSQL versus some other ones?
I guess what I arrived at was if you're getting started between, by the way, there's also this fork of MySQL called MariaDB. And I'm not really in that community, but my understanding is that has more of the open source energy around it now. And I'm not sure about the development velocity or anything. But anyway, just thinking of open source relational database management systems like MySQL, maybe MariaDB and Postgres, I'd say that if you're early in a project and you're selecting one of them, I don't really think performance should be a big concern because they're going to roughly be about the same. The main job of the database management system is going to be inserting data that the web application is sending as a client. All the forms on your web app and that sort of thing, like that's going to be writing data into the database. And then, of course, querying that data back out. So I think they're roughly the same in terms of most web application use cases at a high level. If you wanted to go into greater depth, what you could do is you could benchmark each of them in terms of the number of, usually the benchmark that people mention is transactions per second. A transaction would be one write into the database or one read from the database, for example. And what you could do is you could compare the performance of them and you could say, how fast can MySQL write 10,000 individual inserts into the database? How much time did that take versus Postgres? And that would be one way to answer this question. Like a lot of things in technology, the most weaselly answer is it depends. And it really depends on what kind of performance you're after and how much sophistication you want to put into the answer.
Someone on Reddit right now is plugging in their keyboard for a brutal response about why one is better than the other. But I find, for the most part, you're right, that I don't see a massive amount of performance change. I do find some tooling to be better in some ecosystems than the other, but I've never benchmarked them. Have you?
And I've used both professionally, including, I'd say, at high scale at two different companies that achieved some success in sort of consumer scale, available globally, used by consumers. One was e-commerce, one was an education platform. And one used MySQL, one used Postgres. What's interesting, like with performance is, again, there's a handful of things at a minimum that you would look at for performance. And just kind of the raw insert or read rate is one of them, but it's not all of the answer. There's all kinds of different things you might do to improve the overall application experience or the scalability that might be outside of the database itself. And then there's also a lot of configuration you can do within the database where you trade off concurrency guarantees and performance to make a particular operation faster. So what the database is trying to do is it's trying to accommodate as many concurrent operations as possible. So let's say 100 different users submitting a form at the same time and isolating those operations so that each of those are treated as if they were the only operations occurring at that time. For example, if you and I are both accessing the database at the same time and you inserted some data and your transactional data should be private to you, and we're talking about milliseconds of time here, where this is not like an hour of time, but within particular interactions with the database from the client or the web application, one of the biggest challenges for performance, kind of going down a rabbit hole here, but let me just summarize, like, because this comes up a lot with performance, is when you're looking at your transactions per second, there's different trade-offs you can make about the isolation of those transactions that can give you better performance, but then they have certain trade-offs as far as like when that data may be read by other concurrent users of the database. So the database I find it really interesting. Like it really is the main brain of the web application in terms of the data going in and out that the web application is. And again, we're talking about web apps here. There's other use cases, but I know you all work with Ruby on Rails as well. And that's probably where a lot of the audience is for the podcast. I'll reel it back a little. So as far as whether MySQL and Postgres, how they compare, and also in full disclosure, it's not really something that I study. I've been working mostly with Postgres, but I do know in general, when you look across different database engines, what you kind of want to consider is like the write speed, the read speed, how you might scale both writes, how you might scale reads. And then you'll run into these discussions around transaction isolation and the trade-offs there. You can trade it off less isolation guarantees and get more performance.
Hi there, Julie here. I would like to take a moment to thank GoRails for sponsoring this episode. When I was first starting out, I struggled with finding up-to-date content to help me level up. Then I learned about GoRails. Not only does GoRails provide new screencasts weekly, they also have two fantastic instructors that break down complex topics into digestible chunks. On top of that, I really appreciate when they explain the whys behind the subject. One of my favorite walkthroughs is creating your first Ruby gem from scratch. What a great way to learn by stripping down to just the basics. If you care about leveling up as a Ruby engineer, you can't go wrong with GoRails. Check it out at gorails.com. Something that came out of your response is this concept of concurrency. Can you maybe speak a little bit more to what exactly that means?
I have like something to tack onto that. We are very close, but not quite touching transactions and locking in Rails. And since maybe some of our users don't know that those things exist in Rails, if we wind up talking about those two, that would be great.
Yeah. This is going to be database engine. So when I say engine, I'm talking about Postgres or MySQL for this example. There's going to be implementation differences. But what happens is when you insert a row, for example, for every transaction, there's a corresponding lock type, and locks can either be exclusive or they can be shared. And this is a whole
What is a lock?
deep, in Postgres anyways, a lock could be any database object. There's locks that could be on different database objects, but typically we're talking about a table or a row. So an entire table could be locked. And that would be bad, right? Because again, thinking about concurrency, if I have one write transaction, or if I have one transaction that has taken a lock on the entire table exclusively, that means no other transactions can read from that table. And again, these are milliseconds of time. But the way that shakes out in a Rails app, and this does happen, is a table might be locked or some rows might be locked for reading. And for the duration of that, the query that's trying to read that data is blocked. So it's just trying to access the data. So if you think about the whole flow, like the programmer wrote some active record code. The active record code gets turned into SQL. The SQL is a statement that's sent to the database trying to read some data, let's say. If it is trying to read data that it's not available to it, it's just going to wait until it can. And then based on how the application is configured, that might actually cause errors in the form of requests timing out, and the end user will see an error or that sort of thing. So there's this like balancing act of higher levels of concurrency with minimal locking. And most of this doesn't matter when you have any sort of like modern database engine, when you've got minimal activity for like a feature. And by that, I mean like minimal access or usage of it. Like you have tens or hundreds of users as opposed to thousands or hundreds of thousands or millions. It's really, really unlikely you're going to run into what they call lock contention, where you have those operations occurring at the same time and contending with each other. When you get into higher levels of scale, like if your application is successful and you have a lot of concurrent usage, that's where you can run into the lock contention. Without attempting to explain a lot of this, because I'm not an expert and it's a huge topic. Basically, the takeaway for anyone that wants to research this more is each transaction has an associated lock, and each operation is being conducted inside of a transaction. And database performance is often described in terms of transactions per second.
So does that mean that if we wanted to lock a table, we would have to write a query to lock it? I don't know if this is being...
Yeah, good. That's a good question. Yeah, what you're getting at was locking the table manually or deliberately. That is something you can do. That would be called an explicit lock that you're taking. You would do that if you wanted to safeguard certain types of concurrent access. It's not something you're likely to do. What's actually happening most of the time. So yeah, just as a frame of reference for folks listening, like this is what's happening more within Postgres when your application queries are landing on Postgres from the active record code that you wrote, or if you wrote SQL on the Rails app side. If one of your queries is timing out, it may be because your query is waiting to acquire a lock that it can't acquire because the thing it's trying to acquire is blocked on something else that's holding that lock exclusively. So if you think about it, it wouldn't make sense if most of the operations on your database involved exclusive locks, right? Because you'd have very poor concurrency. Like most operations use shared locks, and you want to minimize exclusive locks. However, you don't really directly influence them. It's more about awareness about what's, in my career experience and learning experience has been building my awareness about the locking behavior that's happening from the code that I write and the actions I'm taking. So Andrew had mentioned like Rails migrations. So most Rails migrations are going to be The kind where you're changing the structure of the table, not where you're populating data. You can use Rails migrations for different purposes, but the kind where you're modifying the structure, those are typically going to be exclusive locks taken. And you think about like concurrent users, right? Like two people racing for the same information at the same time. You wouldn't want to provide different data for them. If you imagine like two people racing for something, that's what I've heard before and makes sense to me as like a way to think about it. You'd have to do what they call a pessimistic lock. You'd have to like lock it early. So you'd say like, most people want to read this data, but I'm going to actually change the structure of this table. And I'm not going to like bring the application down or the database down to do that. I'm going to do it online while the activity is happening because we don't want to take down the app if we don't need to. Then the users couldn't do anything. So I'm going to actually change this table structure essentially like in real time at the same time people are trying to access the data. And in order to safeguard them from having invalid data or corrupted data, I'm going to actually lock the table briefly. Then that lock will no longer be in effect when that table change is complete. And then those two people racing that maybe were blocked temporarily, now they can access the data, but they're both getting consistent data.
I'm going to give a simple example to kind of sum this up. We're talking a lot about reading. I think the easiest way to imagine this, if this is the first time you're hearing about locking, the easiest way to think about it is like, if Julie and I are editing the same document, like she's editing a document on her computer and I'm editing the same document on my computer, and she happens to save something before I hit save, but then all of a sudden I hit save, and what gets actually returned to her? Is it her data or is it my data? So that's a situation where like, I should not be able to change it until after her change is committed, whether you're doing optimistic locking or pessimistic locking, where you actually have a lock version. And if you have two objects with the same lock version, Rails is smart enough to be like, hey, this is a stale object. We're in a bad state here. I think that simple example might help a couple of people.
Well, I'm just going to move on to the next question here. I'm going to ask you, why would you choose PostgreSQL over MySQL, for example? I noticed that you said you had done work in both, but you now work mainly with Postgres.
I think as far as someone in 2023 selecting a database, yeah, it's a really tough situation. Like I don't really have any sort of business interest or vested interest. I guess I can share my experience and my enthusiasm for it and then maybe influence others. I started to use it mostly just because it was the default from Heroku. I'd say it was around 2010 or 2011 era. So Heroku is a great platform as a service for anyone that hasn't used it. And it really was a game changer for making deployment of Rails applications super easy at the time. What the experience was at the time, if I remember, was like Postgres was just there for Heroku. So if you needed to go into the database and either run SQL or explore it or that sort of thing, you would be doing that with Postgres. And over time, I've learned that a lot of the Heroku folks were really Postgres enthusiasts as well. And so I think it came out in their documentation, user guides, their kind of premium support, I would say, possibly for free. So that was my experience. And then getting started with it. And then I'd say two other big things were one a little bit negative and then one positive. One negative was I did have the experience prior to that of using MySQL and being surprised. And again, this was like late 2000s, but being surprised with a truncation where inserting some data at the time that exceeded the size of the column. So like, let's say I'm writing in a user record and I have the first name column, but I have it set to only allow 10 characters. And I insert a name that has 11 characters. What I recall was at the time, like in MySQL, it would truncate data. So it would only take the first 10 and I'd lose one letter of the name. That's not good. You don't want your database to do that. So the positive side is having the experience of working at this startup, the education-oriented startup, and seeing the scale that can be achieved with just a single Postgres primary database. We did have a single replica as well. We had this relatively simple Postgres architecture for folks that are familiar with running a single database and then splitting some writes and reads. What it wasn't was super complicated with like a distributed database engine with multiple writer nodes and that sort of thing. It's also a relatively older and proven scaling pattern where we were really just using the same technology, but scaling vertically, spending more money, buying larger instances. And then the positive experience for me there was seeing how much load could be handled by Postgres without having to introduce a lot of new complicated technology.
The number one reason startups fail is that they run out of money. There are so many ways for startups to lose money. Downtime should not be one. Recent studies found that downtime can cost $427 per minute for small businesses and up to $9,000 per minute for medium-sized businesses. That's every single minute. A monthly subscription with Honeybadger helps you prevent costly downtime by giving you all the monitoring you need in one easy-to-use platform so you can quickly understand what's going on and how to fix it, which helps you stay in business. Get started today in as little as 5 minutes at honeybadger.io with plans starting at free. Yeah, you heard me, free. A big thank you to Honeybadger for sponsoring this episode of Ruby for All. One thing I see a lot of Rails developers reach for, and why I want to ask you about it, is so people out there may get this on their radar, that this is something they may be asked about, may need to know about in the future. pgbouncer is one of the first tools I see people bring in when they're like, okay, we're having some issues with the concurrency or we're having issues with connections. What is pgbouncer, if you know?
Yeah, so pgbouncer is connection pooler. And in Ruby on Rails, you do have connection pooling as well with active record. So what that means is each SQL statement that's being issued against the database server from the application is going to take a database connection. So it's the client server model. It's going to use a connection to issue that statement. So you get out of the box with active record, and I believe with other web application frameworks, you get an application side connection pool. In addition to that, some folks will run infrastructure level connection poolers like pgbouncer to add an additional proxy layer between the client application and the database server. Primarily, one of the main benefits that brings in a situation where you're running out of connections without it is it can more efficiently reuse connections. It's pretty common in Postgres. It's in the Postgres world, folks that are scaling up, if they're starting to run into performance problems with their current database. Let's say you've got a 64 gigabyte Postgres server. That's your primary database server backing your Rails application. If you start to exceed the number of concurrent connections, and again, this would happen if you have a very successful app, like your app is getting used a lot. There's a lot of usage that's driving that growth. If you start to get into that problem, then introducing something like pgbouncer could offer you performance advantages with the connection usage without having to change your database server. It may or may not allow you to do that. You may also still, with pgbouncer, you still may need to scale up. Each connection, if you think about it in terms of the server resources it's using some resources. So it's using some CPU and memory and disk, depending on what's happening. Yeah, so pgbouncer is typically discussed in a scaling context and typically about managing transactions and connections more efficiently.
I had a question about whether we should use a join table to connect to other tables together. Like, for example, if I had a user table and I want to develop a relationship with that user, like let's say you want to be a friend with another user, would you do an array column that says like friends and then list the friends, or would you use join table that connects it with itself?
Yeah, that makes sense. You're talking about like modeling the friendship if you gave it a noun between two friends as a table, possibly, or a different data structure where, yeah, I guess each friend could have its own friendships modeled like as a column, like as an array column with integers. So yeah, like everything, it depends. I think my general recommendation is it's the roots of relational database engines. There's a lot of math involved if you get into relations and things, but just in terms of a typical layout and relational data models, if you think about it, there's been decades of optimizations put into performing SQL queries that join tables together. There was kind of an industry trend for, a decade plus now that discouraged expressing relationships between data as normalized data structures. And I'm talking about like document stores, for example. What you could do, you could achieve either way, and either way is technically valid. It's just about which trade-offs you want. So for example, if you stored the friendships on that table, then in order to get that information with Postgres anyways, you would need to read the column, and then you would perform an unnest of those IDs, like in an array column. And then you would have those IDs, and then you would need to perform another SQL query to the other table using those IDs. So you might do that as like a select star from friends where the IDs are in this list of IDs. And that would give you those friends. If you did it with a join table, then you would have a different SQL statement as a result. And, what you could do is you could compare if it was really critical to your application. In practice, like you probably wouldn't do this because of time constraints that, if you were doing this as a work project, but maybe as like a learning project or an opportunity to explore the performance aspect of this. With data modeling, it's always kind of like, what are the performance requirements that I need from the app? Does that influence the decision, the direction that you go? And performance is like how fast you can write rows in and also how fast you can read rows. And then it's also worth considering other consumers of that information. So it's really common at businesses where you might write in data. So like, let's use this friends and friendships example. If you had a data analytics org or a data engineering org at your company, they might also be kind of consumers of this data. And it might be easier for them to go in one direction or the other and read that friendships data out of a column or from a table, depending on how they want to use it. In general, though, I'd say the takeaway is to prefer normalized data structures. I'm not sure if there's enough time to get into like what that really means, but that would be the join approach versus the array column approach. Reach for the array column or JSON data or that sort of thing within the relational database with a lot of caution and good awareness of what the trade-offs are. Usually it doesn't perform as well, and it can have some benefits too.
One thing I just wanted to add to that, I struggled a lot with data modeling early on. And one thing that started to become almost like a rule for me, when you're making that decision specifically, Julie, do I need a table or can I just express that these are the person's friends, these are their IDs? Think about what else you may want to express about that friendship. Like what made the users want to express about that friendship? Like maybe a certain level of permission that they can see a certain amount, or maybe they want to like put them in a group. And if you're putting them all as IDs, there's no way for you to expand on that relationship. And the biggest one I see with this is the first model people build in their Rails apps is user, and it should be account, because I almost always see it. And I've done it before where you start with user, suddenly you need accounts and teams and all this other stuff. Just start with account and add the user belongs to the account. Just start there. I'm telling you people. Andy, I would really like to schedule another one with you because we have more to do. And I feel like this is like really great information, especially for people who are getting new. Like these are new terms. This is stuff that they will eventually learn about. But I think giving them this head start and like, oh, what is locking? I've heard that. I don't know. But now, Andy, you told me. So we would love to get you back on is basically the gist.
Yeah, I'd love to come back. We didn't really get into like indexes and stuff. And
yeah,
locking is not even something I would say I know a ton about. I hope there was some useful information in there. But yeah, I'd love to talk about indexes and query performance and stuff like that if folks are interested about that. Yeah.
So Andy will be coming back. We will make that happen because I have more questions too. Like you maybe even think of stuff while you were talking like, oh, well, wait, how does blah, blah, blah work?
Julie and I discussed like a little prep doc. We talked about sharing that out too. So I'll make sure that you guys have that and happy to field any more questions from folks as well.
Where can people find you online if they have such questions?
Yes, they can find me on Twitter for the time being anyways, at ANDATKI and Aptkey, or they can find me at andyatkinson.com.
Cool. We will put that in the show notes. Andy, thank you so much for coming on because my brain is bursting with database knowledge now. So we'll get you back. We'll get more of that to y'all listening. And for the rest of y'all, we will see you next week. Bye.
Thanks, Andy. Bye, everyone.